The GMAETS 41's academic firepower once again is back. Guys, you're welcome to the GMAETS 41's live class. We are going to be dealing with what supposedly can be referred to as JAMB mathematics, of course, WAEC further maths as well too. And don't forget, this aspect of maths is also being treated by advanced level in their elementary mathematics. So once again, you are welcome to this live class. We used to do that, so we have some super showdown words on this topic tonight. If you join the class right away, do not waste any further time. Share the links to your friends, share it to various groups you're part of, especially to people that are preparing, scholars that are preparing for the forthcoming professional examination, JAMB and WAEC in Nigeria. And if you're connecting from any other part of the world, for sure you have friends that definitely need this class. And so what is holding you back? Share the link to them. Give this lesson thumbs up as usual. And remember, you can support this channel. If you are yet to subscribe, hit the subscription bell, turn on the notification bell so that once I upload any content or I am live like this, you will be personally notified. Good evening, Paul Dorcas. You're welcome to join the class. You're welcome. So while we look forward to having other friends join us, we will not waste further time. The class is supposed to have kicked off by 9:10 p.m. Nigerian time. This is 9:22 already, so some minutes behind schedule. So as you have on the board, we are dealing with coordinate geometry. When you talk about coordinate geometry, you are looking at the concept of lines. You are looking at the concept of what? Lines. Now this class, like I said, is going to be a super showdown class. There is no time to waste. And so, I am not going to make any review about this topic. Please, do yourself good. Perhaps at the end of this particular live class, you want to learn more about stuff that I'm going to do in this class. Simply slide through to the GMAETS 41's Math 101/Math 102 playlist right on this channel. Go to our homepage, okay, on this channel, and then go to the playlist. Tap on the playlist. You have courses, subjects available. They will appear. Scroll, locate Math 101/Math 102. Tap on that particular playlist. The video lessons will open up. You see the topics. Scroll, locate coordinate geometry. You would see video lessons where I treated these stuffs one after the other in terms of the formulas you need, and of course, how to solve questions on them. I'm going to go straight to hitting the questions that we have here with regards to your preparation for your examinations. Kim Bolu, good evening. You're welcome to join the class. It's good to have you here today once again. So like I said, without wasting time, we've got questions here we are going to deal with, and I have this question right away. I'm going to be writing the questions on the board, possibly. So we move on straight to question number 1. Like I said, here you are dealing with lines. A line is made up, is formed by 2 points. If I have a point here and I have another point here, and you connect the 2 points, you have a line. Like I said, I'm not going to do is make a summary of the topic because we've got wonderful video lessons covering this. And so please do yourself good. I've advised you guys, the videos already available on this channel, they are not there for being there for nothing. They are there for you. So topics that I come on live to deal with and other things, we have the video lessons where I took my time step by step to break this concept, full teaching to help you even understand the whole thing about the topic. Therefore, permit me today, should I take permission from you? I don't think. It is your right for me to take permission from you on that. I already told you that the video lessons are available, so you can do yourself good in that. Let's move on to our very first question. As I deal with the questions, I bring out the formulas, you're saying them, okay? But for step-by-step detailed learning of this topic, do yourself good and go to the playlist. I've directed you on what to do. So this is the question I have right here. It goes this way. A straight line makes an angle of 30 degrees with the positive x-axis, and cuts the y-axis at y equal to 5. Now the examiner requests that you find the equation of the straight line. Find the equation of the straight line. So that's the question, and of course we've got options here, right? Option A, root 3y equal to x plus 5 root 3. Option B, root 3y equal to minus x plus 5 root y. Option C, y equal to x plus 5. And then option D, y equal to 1 over 10x. You know, that is x over 10 actually. 1 over 10 x, and then plus 5. So that is the question and the options dictated. So we're going to solve this straight, after which I will still go over the options for you to see what the correct answer is. Boy FX, I love your teachings. Thank you very much. Thank you. Amber Wijninga, option B already. This is smart, you know. Okay, but I don't know if it is option B. Let's solve it. Are you sure you even waited for the question to have been written on the board? Okay, let's go. Now you are given a straight line. We are told that the straight line made an angle of 30 degrees with the horizontal. Dear friends, whenever you are given the angle that the straight line makes with the horizontal, from that angle you can get the gradient of a straight line. And although I don't wish to make a summary of this topic in this live class, I'd like to tell you this as a secret, the key to dealing with coordinate geometry when it comes to all these things about lines. You should know how to get the gradient of a line. My beloved friends out there, if you know the gradient of any line and you know the intercept per se, even when the intercept is not given, and you know the gradient as well as 2 points where the straight line passed, you can determine the equation of that line. So here we've got that the line made an angle of 30 degrees. So quickly, the gradient M, we use M for gradient. The gradient is equal to tan theta, and that tan theta is equal to tan 30. So what is the value of tan 30? Now, if you are seated in JAMB examination, the truth is the calculator in the system does not have trig function. And the good thing is you don't need calculator to be able to get sine, cos, and tan of special angles. On this channel, I have special videos dedicated to how to obtain the sine, cos, and tan of special angle. And how do you actually even know special angles? I'm going to give you the guideline, the trick. But again, I have a video lesson on this channel in that Math 101/Math 102 dedicated to teaching students how to know their special angles. Now listen to me as I tell you about the Omaka's 30-15-15-30 degree generator, which is used for identifying special angles. We start with 0 degrees. After 0 degrees, you add 30. 0 plus 30 is 30 degrees. So 0 degrees is a special angle, 30 degrees is a special angle. After the first addition of 30, the next addition is you add 15 to that 30. If you add 15 to 30, you get 45. So 45 is a special angle. After 45, to get this next special angle, you add 15 again. If you add 15 to 45, you get 60 degrees. Therefore, 60 degrees is a special angle. After that, 60 degrees, next you add 30. If you add 30 to 60, you get 90 degrees. So 90 degrees is a special angle. And this covers the whole special angles you have in the first quadrant. 0, 30, 45, 60, and 90. How did I generate it? The 30, 15, 15, 30 degrees generator. Once again, let's go. 0 plus 30 plus 15 plus 15 plus 30. Repeat this all along, and then you get to 360. If you hit 90, for example, the next is to add 30, add 15, add 15, add 30. That takes you to 180, which covers the second quadrant. Moving to the third quadrant, add 30 again to the 180, you get, of course, 210, add 15, add 15, add 30. It lands you on 270, which covers the third quadrant. Move again from 270, add 30, add 15, add 15, add 30. It lands you on 360. That covers the whole special angle in the fourth quadrant. So this is the way you generate your special angles. Are you getting me right? And when talking about special angles, there is this two special triangle that you use in getting their values. And of course, for this one, I will show you for 30 degrees, this is the triangle you use. Okay? Like I said, I have special video lessons guiding you on this. So I advise you, please, to learn more, reach out for those lessons. This channel has covered all of these stuff for you. It's now left for you to make use of it. Now, if I'm trying to get the value of tan 30, tan is lower, opposite of adjacent. Using this 30 degrees, opposite 1 over adjacent root 3. Which simply means that tan 30 is equal to 1 over what? Root 3. And that is cool. Now I have obtained the gradient. Once I know the gradient, my problem is 98% solved. The next thing I want to now ask myself is, do I know 2 points where this said line passed through? This line whose equation they said I should find. The points that it passed through, the x and y value, do I know it? If examiner does not give you the point where the straight line passed through, then the examiner will definitely give you the intercept. The intercept on the vertical axis. And in this case, we're given the intercept instead of the point that the line passed through. We'll solve question in the case of finding the equation of a straight line that passed through a given point. So don't worry, when we get there, we'll cross it. Now that I get this gradient, 1 over square root of 3, the next thing is to look at the question and find out that I know the value of the intercept. The intercept, we use C for it. And that C is given to be equal to 5. I'll now recall the equation of a straight line when I know equation of a straight line when I know the gradient and the intercept. The equation is given as y equal to mx plus c. Take note of that. This is the equation of a straight line given the gradient m and the intercept c. So in this case, I'll just simply substitute for m and c, and the equation of this line that made an angle of 30 degrees with the horizontal having an intercept of y equal to 5 is given as y equal to n. Our m is 1 over root 3. We are multiplying it by x and then plus the intercept, which is 5. Please take note, this y given to you here is not the value of this y. As a matter of fact, in the equation of a straight line, you must have y and x in it. This y, if you read the question, you would see clearly that the examiner said, and cuts the y-axis at y equal to 5. It's just like somebody giving you a graph, and then you have something like this. So where the graph cuts this y-axis is your intercept c. We can say the value of y at this point is that c. That's the meaning of that guy. And then the line made an angle of 30 degrees with the horizontal. So this is just a rough sketch, where here the value of the intercept is 5 as given. So from here, we've just got to simplify, because from the option given to us, from the options given to us, let me see, where is the question? Good. Y was written on one side, the left-hand side, and then x and the constants were moved to the right-hand side. So what we are going to do is this root 3 will clear the fraction. I'm going to wipe this place, so I will use all this space. I'll clear this fraction. To clear the fraction, use the LCM to multiply all the numerators. We've done a lot of stuff like that. So this is root 3 times y. And then you will get y root 3. or simply root 3 and then y in front. The choice is yours. But that y is not going to be inside the square, it's just the outside. Then equal to that LCM root 3, use it to multiply this numerator here, it will cancel itself. You'll be left with x. Then plus, use that root 3, the LCM, to multiply this 5, you'll get 5 root 3. Therefore, this is the solution. And of course, from the option that I dictated, option A, root 3y equal to x plus 5 root 3. Root 3y equal to x plus 5 root 3. And of course, without wasting time, that is our answer. I hope that makes sense. So option A rather, is the correct option. Okay, option A is the correct option. Some of you selected option B. What is option B here? Option B is root 3y equal to minus x plus 5 root 3. This is not minus. You can see that it is plus. There is nothing that brought minus here. Nothing brought minus. Tan 30 is equal to 1 over root 3, not minus 1 over root 3. The reason is because 30 degrees is in the first quadrant. And in the first quadrant, both sine, cos, and tan, all three trigonometric functions are positive in that quadrant. All right, we are done with this particular question. Let's move on to question number 2. The second question we've got here that we're going to solve reads. So I'm going to copy it to the board. Let's see the space occupied, that the camera can cover from the left. Can I manage this? Let's see how it goes. All right, so I can go backward a little. Don't mind me, I'm trying to measure now the space I can maintain so that it doesn't cut off, it did not show up. Good. So I'm going to maintain this space so that it won't cut off from your view. Question number 2, I've got this. Find the equation of the straight line. Q2. Find the equation of the straight line. Through the point minus 2, 3 and perpendicular to now we're given this equation 4x plus 3y minus 5 equal to 0. Good. Find the equation of the straight line through the points minus 2, 3 and perpendicular to 4x plus 3y minus 5 equal to 0. We've got these options. A, 4x plus 5y plus 3 equal to 0. B, 5x minus 2y minus 11 equal to 0. C, 3x minus 4y plus 18 equal to 0. And then D, 3x plus 2y minus 18 equal to 0. So we're going to solve these once again and see. I hope it didn't cut off from your view. Let me check from this streaming device. All right, so where are we? Okay, good. It's within range. I got it. So let's solve these and then see what the correct option would be. We are required to find equation of a straight line. That line, the examiner said, pass through minus 2, 3. So they gave us the point through which the line passed. But there is something about that line we are told that the line is perpendicular to this guy. This equation you are seeing is the equation of a straight line. How do you actually identify equation of a straight line? Although I have told you, reach out for the GMAT 41's playlist. You see, there are a lot of video lessons being made available, pre-recorded videos presently. It's not all about this live class. There are a lot of uploads in this channel, right? Wonderful content for you guys. So it's not always live. One of you dear friends made a post, a comment one chemistry, that's organic chemistry, IUPAC nomenclature. That was on, I think, alkanals and alkanone, they're about. And the scholar was like, he doesn't comment. Normally whenever he comes to the platform, various platforms to watch something and stuff like that. But seeing the way I broke down the concept of IUPAC nomenclature of that carbonyl compound, like he was super impressed. In our previous, that was yesterday, I guess, I treated IUPAC nomenclature. I kept encouraging you guys to visit the playlist on Chem 102, where you view IUPAC nomenclatures of alkane, alkyne, alkanol, alkanones. So make sure you visit there. Watch these videos. Share the links to your friends. Someone out there needs it. Someone out there needs it in order to survive what he or she is studying. Please. And of course, I'm counting on you guys to keep pushing this channel, to the public. Make it viral. So let's move on. Now that we are told that the perpendicular, the line whose equation we are to find is perpendicular to this guy. For every equation of a straight line, how do we identify it? The power of x and the power of y must be 1. In fact, we say that a straight line is an equation of degree 1 in x and y. That is to say, x and y, they have power 1. So that's it. Now, since we are told that the straight line whose equation we are to find is perpendicular to this guy, you must remember that gradient of a perpendicular line is equal to minus 1 all over gradient of a straight line. So here, what we're going to do, that perpendicular line whose equation is say we should find. The perpendicular line is also a straight line, right? But it's just like if I call this the straight line, then this will be taken to be perpendicular to it. If I take this, let's say PQ to be a straight line, then this one, if I call it ST, I'll consider this to be a perpendicular line to it. If I take ST to be a straight line, I will take PQ to be perpendicular. So that's just the whole idea there, right? Both straight line and perpendicular line or normal line, whatever you call it, they are all straight lines. Even tangent is a straight line. Now, since this straight line whose equation we are to find is perpendicular to this guy, we can get the gradient of that perpendicular line from this one. How do we do that? We will get the gradient of this straight line. Since the line whose equation we are to find is perpendicular to this, we will now use gradient of perpendicular line equal to minus 1 over gradient of the straight line. But how can we get the gradient of this line? How? We have to standardize. To standardize, this guy means you have to make y subject of the formula. So what I'm trying to say is that for us to get the gradient of this line, I will make y subject to the formula. And if you make y subject to the formula here, it's simple. 4x will cross to become minus 4x on the right hand side. Minus 5 will cross to become plus 5 on the right hand side. So that 3y will be equal to minus 4x plus 5. Then make y subject to the formula, you divide through by 3. Which means you're going to get minus 4 over 3x and then plus 5 over 3. Then you get the gradient from there. But I'm going to tell you the quickest thing to do whenever you are getting gradient of any straight line equation given to you. This is the fastest thing. Change the sign of the coefficient of y. I repeat, to get the gradient of this line, n, gradient of this line, that's gradient of the straight line. Change the sign of the coefficient of this y. If you change this sign, this is plus 3, you change it, you're going to get minus 3. Then divide it by the coefficient of, oh no, I'm sorry about that. I was talking of changing the sign of the coefficient of x rather. So once again, change the sign of the coefficient of x. The coefficient of x here is positive 4 plus 4. If you change it, you get minus 4. If you change the sign of this coefficient of x, divide it by the coefficient of y. The coefficient of y here is positive 3, so just simply divide by 3. Is that okay? Once again, change the sign of the coefficient of x, divide it by the coefficient of y. That gives you the gradient straight. Is that clear? And it's the same as what I told you earlier, that if you standardize this by making y subject to the formula, it's going to be minus 4x all over 3 plus 5 over 3. If you compare this equation with this one, m, y equal to mx plus c. The gradient is the coefficient of x. Here, the coefficient of x is minus 4 over 3, which is what I've just showed you here. Change the sign of the coefficient of x. Divide it by the coefficient of y, you get the gradient directly. So that's the trick. The fastest thing you should do in exam. Now that I've gotten the gradient of this line, we were told that the line whose equation we should find, the straight line whose equation we have to look for, that straight line is perpendicular to this one. Therefore, I can say that gradient of the perpendicular line, I prefer using this symbol. The formula is equal to minus 1 all over gradient of the straight line. I am taking this to be the straight line, whereas the line whose equation we have to find is now perpendicular to this one. So this gradient I obtained is the gradient of this line. The gradient of the perpendicular line will now be equal to minus 1 all over gradient of this line. Therefore, gradient of the perpendicular line, whose equation we have to get, will be minus 1 all over gradient of the straight line, which is minus 4 over 3. If you simplify this, you are going to get 3 over 4. Minus minus we cancel, this 3 will climb. Move to the numerator, multiply this one, you get 3 over 4. So I have gotten the gradient of this perpendicular line, whose equation I am to find. And remember, I told you once you get the gradient of any line, and you know the point through which that line passed through, you can calculate, you can evaluate, you can determine, you can get the equation of that line. So my problem is solved here. From the equation, we are told the point through which the perpendicular line passed. So I'll now use my equation of perpendicular line y minus y1 equal to m perpendicular open bracket x minus x1. This is the equation you use there, right? Equation of a perpendicular line is given as this. It is the same as the equation of straight line, where you use only n. The only difference is that for perpendicular line, the gradient you are using is the gradient of the perpendicular line. Substitute the value of x1 and y1. x1 and y1 are the points given here. x1 is minus 2, y1 is 3. So if you fix, you're going to get y minus y1, which is 3. M perpendicular is 3 over 4. That's the gradient of the perpendicular line. Open bracket x minus x1. Now watch. X minus x1. Remember I told you today's class is going to be a super showdown class. There are a lot of things I wouldn't be showing technically on the board because you don't need them. Your knowledge of basic arithmetic should guide you. And I've told you, dear friends, I respect and value basic level of learning. So if you have problems, challenges with all these basic calculation and that thing, why not follow me on the GMAETS 41's basic class channel? I've said this time and again. So that there, at least at your convenience, from wherever you are connecting to these classes from, you can start learning gradually all those things. Give yourself just 2-3 months. Your problem is solved in all these basic arithmetics. You can now be dealing with all these tops with great speed. I'll take my time too much to explain concept, but of course it's for your good. So sometimes I might decide not to do that. This is minus, follow come minus in the formula of the equation of that line. The value of x1 we want to substitute has its own minus. So it's going to be minus minus 2. Minus the x1 is minus 2. Minus minus is going to give us plus. So from here you clear the LCM. Now watch, clear the fraction. As I'm clearing the fraction, I'll be opening up this bracket at the same time. You know that these 3 will multiply this bracket, you get 3x plus 6. Then the LCM is 4. Use that 4 to clear the fraction, which means the 4 will multiply each of the numerators. Now watch. 4 times y will give us 4y. 4 times minus 12 will give us 4 times minus 3 will give us minus 12. Equal to. That 4 will multiply this part, this top here, this 3. But the 4 will cancel this 4 under. So you'll be left with 3. Then the 3 will now open up this bracket, which will give you 3x plus 6. Now the way that the way the options were presented, is such that they moved all the terms to the left-hand side and made it equal to 0. So we are going to do the same thing. I'll move all these things to the left-hand side and then equate to 0 so that we can get the value, the equation of that line. So this is going to be 4y. Move this 3x to the left, you get minus 3x. Then move this 6 to the left. If this 6 plus 6 is crossing this equality sign, it changes to minus 6, meeting its like term minus 12. You're now going to get minus 12 minus 6. Minus 12 minus 6 is going to give you minus 18, and that is equal to 0. This is the equation of this perpendicular line that passed through minus 2, 3. And now you want to listen to the option. Option A, 4x plus 5y. In fact, that is off because y is not 5. Y is not 5, so no need of wasting time reading it to the end. Option B, 5x minus 2y. In fact, x, the quotient is not 5. Y, the quotient is not 2, so option B is off. Option C, 3x minus 4y plus 18. You want to pause a little. 3x minus 4y plus 18. You want to pause because all the coefficients and this constant, they appeared in that. It's just like a sign change. And of course, there's something you would do to likely get that option. Option D, just listen to that so that you throw off option D. 3x minus, oh no, not minus. 3x plus 2y. 2y. Y here, the quotient is 4, not 2. So option D is off. Now look at this option C. Option C, I'm going to write it here. Option C is 3x minus 4y plus 18 equal to 0. Do you agree that this option C provided and what I solved here, they are the same? It's simply multiplying each of these guys, multiply through by negative 1. If you multiply this by minus 1, it will change to minus 4, which is what we have here. Multiply this minus 3x by minus 1, minus times minus will change to positive. So that is why here there is no minus in front of the 3 again. Multiply minus 18 by minus 1, you will get plus 18. That is why this minus changed to plus. Whatever you do to the left, you do it to the right. So coming to this 0, multiply by minus 1, you still maintain your word 0. Therefore, the correct option is option C. Elam Victory, thank you very much. Welcome to the GMAETS 41's Platinum level. Thank you for joining this wonderful channel. And of course, you will be glad that you did. You're welcome. You're welcome. All right, we're moving on. We are done with this question, please, and we shall be going on. Obia Julie, let's see your hand. You know, do you want to know what? Okay, is a trick to the topic I'm teaching. Obia Julie, so funny. Don't mind me, it's Mike, okay? It's Mike. I just had to place it there today. Now we are moving on to the next question. Please finish up with what you have here. You can screenshot, you know, to be fast. And so that we'll move on to the next question. No time. No time. All right, so believing that you're done copying or likely screenshotting, I'll wipe this part. Let's move on to the third question. See, I tried to come up with some tricky questions. Yeah, likely tricky questions for JAMB and WAEC. Questions that I made, you know, though the technicality is not much, so it's not a big deal. Now, let's look at this one. Question number 3. Q3. The gradient of a curve is 2x plus 7. The gradient of a curve is 2x plus 7, and the curve passes. And the curve passes through the point 2, 0. Through the points 2, 0. Find the equation of the curve. So that's the question. And now listen to the options as I dictate. Option A, y equal to x squared plus 14x plus 11. Option B, y equal to x squared plus 7x plus 9. Option C, y equal to x squared plus 7x minus 18. Option D, y equal to x squared plus 7x plus 18. This is a pretty technical question, but you see, one thing about what you learn is you want to always use the knowledge of the known to attack the unknown. When I just saw this question, it flipped through when I just turned the page and I saw it. I was like, this is a question to solve for my friends. And yeah, though just for once, I've come across this particular question. And it's something I should solve for my friends. Let's see how we handle that. Now, you want to understand something that, you see, the gradient of a curve has been given to you. A curve is different from straight line. Straight line is something like this, as we know. A curve goes, anyhow you want to draw the curve, not a straight line. So you see, we were asked to find the equation of a curve. So this, let's say that equation of this curve. How do you differentiate the equation of a curve from the equation of a straight line? Like I told you earlier, equation of a straight line, the power of x and y must be 1. It is a polynomial of degree 1 in x and y, meaning that x and y, their powers are 1. That is how you identify a straight line. Once the power of x and y are no longer 1. Once the powers of x and y are no longer 1, powers are no longer 1, or power is no longer 1. When the powers of x and y are no longer 1, then that equation becomes a curve. So if I give you something and then you have either x to the power of 2, just like you read from the option, that guy is a curve. Is a curve. So we're going to solve and get the equation of this curve. But dear friends, let's look at the question given to us. The examiner went ahead to give us the gradient of the curve. So I'm going to write, okay, fine. The gradient has been given to us to be 2x plus 7. They gave us the gradient. But did you know what? This is why at the end of this class, please, I urge you, visit our playlist on this channel. Look out for Math 101/Math 102. You need to get further information. There is this aspect somehow that JAMB doesn't usually cover. Yeah, JAMB doesn't usually cover that aspect. But WAEC can cover it. Where you will be given a curve equation. Maybe I tell you that you should find the equation of a tangent. Find the equation of what? A tangent that touches or passes through a curve at a point. And I give you the value of the point. Let's assume that this is a curve. And then I tell you that the tangent touched the curve at this point. And I give you the value of this point, say x1, y1. I will give you this curve equation, y equal to, let's say, x raised to power n plus blah, 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 where n is not equal to 1. N is not equal to 1. Because if n is equal to 1, this becomes a straight line. So n is either greater than or less, as the case might be. Most generally greater than 1. So I can tell you to find the equation of this tangent. This is a tangent. A tangent is a straight line. So the equation will still go as y minus y1 equal to m x minus what? x1. If you have to calculate the equation of this tangent, if you have to find it. Which means if I give you this equation of a curve, and I try to find the equation of the tangent, you are using this formula. You know this point x1, y1, the values will likely be given to you. Your problem is to get the gradient. Since you are given the equation of the curve, what would you do to get the gradient? You will differentiate. You will differentiate. If you take my video lesson on first principle, where I broke down the concept of first principle and I derived it 1 plus 1, it's titled something like Calculus Exclusive. That's what I used to title that particular video lesson. You will see where I explained that gradient m is equal to dy dx. Gradient is equal to what? Dy dx. So if you are given a curve equation and you have to get the gradient of that curve, you have to differentiate that curve. If you differentiate that curve, what you got is the gradient. Which means that if somebody is telling me that n is equal to 2x plus 7, this n, which is gradient, I actually obtained it from differentiating the curve. And here the examiner is now asking us, oh yeah, find that curve. Find that curve that was differentiated to get this gradient based on what I'm trying to explain here. So dear friends, since we know that gradient is equal to dy dx, this simply means that this guy given to us, this gradient, which is equal to dy dx, is still the same as 2x plus 7. That's the meaning. Remember, I'm looking for a curve, y equal to something, x raised to the power something, where the power is not 1. You will get that curve from the gradient given to you. Why? Because to get that gradient, you differentiated the curve. I repeat, to get that gradient, this gradient 2x plus 7, you actually differentiated that curve whose equation we are asked to find here. Am I communicating anything, guys? And you remember in, I think, our last class on mathematics, right? Yeah, I treated differentiation. Okay, I treated matrix. That is last 2 classes. I treated differentiation and integration, where I told you if I differentiate this blue marker to get this black marker, if I want to get back my blue marker, I'll have to integrate this black marker. That is why we say that differentiation and integration are opposite. They are opposite. Therefore, if gradient is obtained from differentiating a curve equation, to get that curve equation, you have to integrate the gradient. So coming over here, I will have dy dx equal to this, which means that dy will be equal to 2x plus 7 in brackets dx. I cross multiply. Let's keep that m aside now. I'm wiping this. I just use it to interpret the implication of this. That if you are given a curve, you can get gradient of that curve by differentiating that curve. And that can help to get the equation of a tangent line. We might meet a question like that, I don't know. So if you know that gradient is obtained by differentiating a curve, therefore to get that curve, you integrate the gradient. So all this is I'm doing on the board is just a waste of time. Yeah, just for you to understand. Why do I say waste of time? That is with respect to if you are seated in exam hall. Because it is believed that after what I'm teaching you, I'm coaching you on this, if you're in exam hall and you see a question like this, is to attack. You already know what to do. Then you don't need to be speaking all this grammar. You don't need it. Just go straight. You are given a straight line. Sorry, you are given a gradient. And that gradient was given in terms of a variable x. You have to find a curve. You have to find what? The curve that passed through this. What you have to quickly do, start integrating that gradient. So here, after cross multiplying, I'll put integration sign here. Good enough. I have taught you integration. Integral dy will welcome back our y. I'm trying to get a curve now. Once I integrate this gradient, it will give me that curve that I'm looking for. Come to 2x, integrate it. You know, this is a polynomial function. So to integrate this term 2x, what do? Come to x, add 1 to the power, divide by the power. This is x raised to power 1 already. If you add 1 to the power, you get x raised to power 2. Then divide by that new power 2. If you have x squared over 2, that 2 will cancel this 2 here. Therefore, this term is simply x squared if you integrate it. Once again, add 1 to the power, divide by the power. If you add 1 to this power, you get 2 all over 2. That 2 will divide this 2. Plus, come to this 7, if you integrate a constant. If you integrate a constant, what will happen is simply to welcome the alphabet, the variable you are integrating with respect to. You are integrating with respect to x. Because there you have x in that function given to you. So integrating this constant 7, it will welcome back x, which means it will be 7x. I am done with the integration. This the x is simply telling you integrate x variable. Now that I've integrated, it will go off. It has directed you. Having been done with my integration, I'll put plus c, plus constant of integration. You can use k if you want. You can use a if you want. The choice is yours. The constant of integration you use does not concern anybody. So, my dear friends, I have obtained the curve that they asked me to find. Unfortunately, this answer exactly is not in the option. And the reason is because of this c. You must find the value of this c to complete the curve. Because if a curve equation is given to you, you won't see anything like an unknown constant. It must be a number. So we have to find the value of this c. That is the reason why your examiner gave you this point, that the curve passed through that point 2, 0. So it means that I'll come to this guy now to get my c. Wherever I see y, I'll fix this y coordinate 0. Wherever I see x, I'll fix this x coordinate 2. Once I substitute 0 for y and 2 for x here, the unknown becomes c. I'll calculate it to know the number that guy is. Let's do that and see. I don't want to write the grammar at 2, 0. X equal to 0. That'll be x equal to 2, y equal to 0. I've just explained it. So go straight. For y, fix 0. For x, fix 2 and square it to get 4. Then 7 times 1 times 2, because x is 2, plus c. This will give you 4. This will give you 14. 4 plus 14 is 18. Move the 18 to the left-hand side, collecting like term. C will be equal to minus 18. We can now conclude the equation of that curve that passed through this point 2, 0 will now be, go back to this. Remember I told you this is the curve. The problem you only have is to get your c. Y equal to x squared plus 17x. Then our c is minus 18. This will be plus minus 18, which will give you minus 18. And this is, of course, the answer to that question. Listen once again to the option as I dictate it. Option A, y equal to x squared plus 14x plus 11. Clearly, the coefficient of x is not 14. So that option is off. Again, the constant number is not 11 as we have in option A. It is minus 18. So option A is not the answer. Option B, y equal to x squared plus 7x, x squared plus 7x, then listen, plus 9. The constant is not 9. So B is not the answer. Option C, y equal to x squared plus 7x minus 18. Y equal to x squared plus 7x minus 18. And of course, that's exactly what we have here. The correct option, once again, is C. No need of dictating option D, for that is not the answer. Bram Sprout, you're welcome. Welcome to the class. So we are done with this particular question, and this will take us to our next question, number 4. Let's see what we've got there. Let's see what we have got there. So I've got this particular question. Yeah, JAMB can ask this question. JAMB can ask this question. However, I'd like to state that this particular question is from UNIZIK. Yes, Nnamdi Azikiwe University examination question on Math 102, elementary mathematics. That course is dealt with in second semester. That course is dealt with in second semester. So, our Zika, it's another here. And don't say when I tell you now, sometimes we take things for granted. We take things for granted. See, 100 level. Although this thing is start JAMB/WAEC maths as the case might be. 100 level, how many times will I say this? Listen and listen good. The courses you are doing, most of them, your 100 level are SS1, SS2, SS3, what? Reviewed. They're about 80%. So whenever I tag a particular, maybe class, a JAMB or WAEC, that should not make you say, okay, no need. No need. There is need, or you need it. That could be your exam question. As a matter of fact, there was a particular question I saw in the past question here. And that question was exactly lifted from JAMB. Yeah. It was exactly lifted from JAMB. I don't know who lifted from who, whether JAMB or UNIS. But it doesn't matter. We can always source a question from any place and then test students on that. So question number 4. And the question reads, in fact, I would state the year particularly. So if any Zika is here, you want to go and find out, you can go find out. And it's still coordinate geometry. That is second semester examination 2015/2016 session. 2015/2016 session. Question number 13. Question number 13. Yeah. And the question is tricky, it's technical. Let's get to see it. Determine the equation of the line. Determine the equation of the line. Determine the equation of the line which is parallel to the line, which is parallel to the line, which is parallel to the line 2x, 2y rather, plus x equal to 3, and passes through the midpoint. I love this question. Passes through the midpoint. And passes through the midpoint of -2, 3 and 4, 5. Yeah, pretty technical solution. I'll dictate the options. I'll dictate the option. Enhance shutters. Is this recorded or live? This is live. This is live. So as I am teaching this, it's happening live from Awka, Anambra State in Nigeria. Let's move on, please. Now, listen to the options. Option A, 2x, 2y rather. Option A, 2y equal to x plus 8. Option B, y minus 2x equal to 2. Option C, 2y plus x equal to 9. Option D, y minus x equal to 4. Option E, nota, that is none of the above. Now, how do we deal with this question? Like I said, it's 1 plus 1, even though it's technical a bit. We are asked to determine the equation of the line which is parallel to this line and passes through the midpoint of these 2 points. You know, if you're given this point and this point, this is a straight line. Because this one will give you coordinate of 1 point. This one will give you coordinate of another point. You join them, you get a straight line. Now you have a midpoint, a middle. So like here now you have -2, 3. I'm still going to wipe it. Here you have 4, 5. And we are told that the equation of the line we should get, that line passed through the midpoint of this and this, which means something of this kind. So this is the line whose equation we don't know. Y equal to mx plus c of this guy, we don't know it, question mark. It passed through this midpoint. This midpoint, we don't know the coordinates. Permit me to call the coordinates x, y. Once I calculate or I get the value of this point, this coordinate, I will now convert them to x1, y1 of this line that passed through it. So that's just the whole thing. And remember, I have said this and I repeat again. Whenever you are dealing with equation of straight line, you only need to know 2 things. One, which is the most important, the gradient of that line whose equation you are asked to find. And once you know the gradient, you will smile, you become a big boy or big girl, you know. Just do like this, no stress. Am I communicating? Then the next thing now is to check, did they give you the intercepts, like our very first question? Or did they give you the point through which the line passed, like our second question? In the case they gave us the point through which the line passed, yeah, the midpoint, we are told that the line whose equation we have to find passed through the midpoint. So we don't have problem with the point it passed through. Although we don't know the coordinate of that point, x1, y1 value of that point, but we can calculate it using midpoint formula, since the examiner had stated that that is the midpoint of these 2 points. Anyway, we are coming to this. The first thing I have to do is to get the gradient of this line, whose equation I am looking for. And how do I get it? Take note that we are told that the line is parallel to this one. Determine the equation of the line which is parallel to the line. They gave you this. Now, when 2 lines are parallel, they have equal gradients. When two lines are parallel, they have what I said, equal gradient, the same gradient. Remember, we've solved the one of perpendicular. In that case, the gradient of the perpendicular line is equal to -1 over gradient of the straight line. But when two lines are parallel, right? Parallel, they have equal gradient. I've taught you the one of perpendicular, and I believe you've learned it. When they are parallel, the gradient of this and the gradient of this will be equal. So to get the gradient of the line, whose equation I was asked to find here, since he told me that the equation, the line is parallel to this one, I'll come to this guy and get the gradient of this line. And whenever any equation of a straight line is given to you, you can get the gradient, you can get the intercept. The intercept is the constant number. The gradient is the coefficient of x. But for you to do this, you must standardize that equation. And how do you standardize? I did it for the first question. Just simply make y subject of the formula. Move everything to the right-hand side. Leave y on the left-hand side. And then make that y subject to the formula. If y has a coefficient, you must divide through by that coefficient. But I showed you the fastest trick to doing that. Come to the coefficient of x, change the sign. Here, the coefficient of x is +1. There is invisible 1 here. There's invisible 1. So +1, change the sign, you will get -1. Divide that -1 by the coefficient of this y, which is 2. So the gradient of this line is -1/2. So I'll simply write that n is equal to -1/2. That is the gradient of this line. And good enough, that is also the gradient of that line that we are looking for its equation. It's just like, okay, now they gave us this line, watch. This one, the equation of the line is defined as 2y plus x and then equal to 3. Then this line is parallel to this line. But then this line now, whose equation we don't know, pass through the midpoint of this guy. Since both of them are parallel, they have equal gradient, which means the gradient of this one, whose equation we are looking for, is also equal to the gradient of this one that has been given to us. And we have obtained it to be -1/2. At this point, I will smile. I will do what? Smile. And you can see me smiling. And I hope you're smiling, they're also enjoying this. Now, what I have to do, I've gotten my gradient. The gradient of this line, whose equation I'm looking for, is the same as the gradient of this line because they are parallel. My only problem now is to get the point through which this line passed. And from the question, we are told that it passed through the midpoint. They gave us these two coordinates, -2, 3, and 4, 5. So this is going to be x1, y1, x2, y2. I will use these 2 points to calculate the midpoint, to get the coordinate of the midpoint, where this line passed. That coordinate of the midpoint is what I will now use as the x1, y1 for the equation of the line I am looking for. Permit me to wipe this. Remember, at the end of this lesson, a copy of this live class will be made available. So anything you feel like you want to pick, you can still come back to it. We're moving on. So given these 2 points, the midpoint, let me say, but I wouldn't speak grammar too much here. I'll just hit the point straight. Remember, I've already explained that midpoint where this line, whose equation we are looking for, passed through. If I calculate that midpoint, which I'm going to get the value of x and y, that x and y value, which are the coordinates of the midpoint, will now become my x1 and y1. So how do I get that midpoint formula? So the midpoint formula x1, y1, let me just take it that way, will be equal to this coordinate of the midpoint. I will come to this guy, pick the x coordinate here, pick the x coordinate here, add both of them and divide by 2. Midpoint formula